important because this will be covered in the final exam. As I told you, final lab will be consisting of two exercises, two questions. One will be 2D and one will be 3D. So 3D will start maybe after next week, maybe in the week 12 or 13. Before the final, we'll just cover 2 weeks for 3D, 2 weeks or 3D, 3 weeks for 3D exercises. So usually the final lab will be having two questions. One will be 2D and one will be 3D. So regarding the 2D, you will have something like that, what you see in exercise 9.1. And this drawing 9.1 is similar. If you see, like for example, 9.1, if I go to 9.1, or if I select 9.2, 9.3, and 9.4, these are four exercises are similar in terms of dimensioning, in terms of symbols, because in this exercise you are going to learn some symbols which are important for the final lab as well. So if you read the question here, it's a part drawing actually, 9.1, and whenever we say part drawing, it must have all the details with full information. So here, if you read the question here, we draw the given detailed part drawing with main dimensions, dimension tolerances, geometrical tolerances, and surface roughness symbols. Now here in this exercise, you are going to learn some symbols which are simple, very easy. Like we are going to put the main dimensions. Along with that, we have some dimension tolerances. I will show you how to put those. We have some geometrical tolerances, and we have some surface roughness symbols. Now this is actually these topics, what you see, dimension tolerances, geometrical tolerances, surface, you are going to learn in this theory class as well. Like in the theory class, we started the chapter 3, where we have seen tolerances. So the same idea is being used here in the exercise. Similarly, in chapter 4, in the coming chapters in theory, we are going to see the surface roughness symbol, this one, and we are going to see the geometrical tolerances. So these symbols will cover in the theory and will also cover in the lab. So in theory, you are going to understand why we are using the symbols, how we are going to use the symbols, the concept of using the symbols, understanding, basically in theory. But when it comes to lab, how you are going to show on AutoCAD drawing. When you draw in AutoCAD, how you are going to represent these symbols. Okay. So in this chapter, in this exercise, mostly we're trying to cover, first I'll write it some points here. We're going to cover the surface roughness symbols. Yes. Okay. And so wherever you see this kind of symbols, this one and this one and this one, these are called surface roughness symbols. Then we are going to use leader line, how to use a leader line, how to use a text, how to use a text override. Let's try to move it. Okay. Then we have geometrical tolerancing or tolerances. Also, we'll see diagram triangle, and we're going to see dimensional tolerances. Okay. So these are the things which we are going to cover in these exercises. Now the first one is the surface roughness. Wherever you see these symbols, this one, This one we are going to see that. Leader line means the line with an arrow. We already studied in EGT 101 in the types of line where you discussed about center line, hidden line, hatch line. So there was also one line called leader line. The leader line is nothing but a line with an arrow. A line with an arrow is called a leader line. Here, for example, here if you see this line, if you see this line, it has an arrow here with a leader. So how we are going to use that leader line, and how we are going to use a text. Text means anything you want to type it, like any information here, whatever you see in the drawing, and how you are going to override the text, modify the text. You can override the text. And geometrical tolerances, this one, whatever you see the boxes, the rectangular boxes on the figure. This is one rectangular boxes, this one, and this one, and here on the down there, and this one, okay. And these are all here on the right side. These are all called geometrical tolerances. Just a second. Okay. Whereas was presenting. Okay. Where is that? Okay. Now these are all called geometrical tolerances. Then we are also going to see the datum triangle. Datum triangle is like showing any surface. For example, in the figure on the right side, if you see, there is a small triangle here. We call it as datum triangle. It is just to show the surface. We call it as a triangle, a small triangle. Also here, if you see, there is one more triangle. So this is just an approximate triangle. We are going to show that is called datum. Datum means surface. Datum is also called as datum or surface to indicate any surface. The last one is geometrical tolerances. Sorry. The last one is the dimension tolerances. Okay. Dimension tolerances means we already discussed in the theory, like how you're going to put the limits, like on dimension. For example, if you give dimension, how you're going to provide the limits, like you have 75 plus or minus, how you're going to put this 0.5, how you're going to put in on the right side as well. If you see this one, how you're going to put the limits to any dimension. Like here on the down, you can see basic size is 40, basic size is 20, and you have limits. So this we are going to provide the tolerances. So we'll see one by one. And for this, I have already uploaded the exercise in the Blackboard, as well as there is a video available. So that would definitely help. And this time you have the video with the audio. So it will be easy for you to practice these symbols. So let us just go back and just try to start now. Now this is your exercise. This is just a construction you can you can draw using the dimension. So when you draw it, don't worry about the limits here. For example, you have a size 75 plus or minus 0.5. Don't worry about the limits. Just draw with the basic size. I hope you understood what is basic size. Like for example, here the basic size is 75. Here 60 is the basic size. Here 40 is the basic size. Here 20 is the basic size. So use the basic size to draw, and after drawing it, you can change the size. Like here 50.02. Don't worry about 0.02. Just draw using 50 diameter. So use the basic dimensions to draw the part, and after that we can edit that. I will show you how to edit it. Now here, if you see, you can just draw the two views, front view and sectional front view and side view, using this dimensions. Now here we are going to start with the symbols. For example, I want to put some dimensions here, like 75. And this is 60. like this. But make sure that when you start any drawing, because it's really important, not only this exercise, any exercise, you have to control the dimension. You have to control the dimension style. Like most of the students, they are, they're using just, they're putting the dimensions as it is. Maybe the size is small or big, and you have some zeros coming to the dimension. So you can change the dimension style from here. You can just go to the dimension style. Okay. Also, you can find it here in the edit format. You can also go to the dimension style here. The same thing is available here also in the dimension style. So usually you can set up, you know, like here I usually go with the dimension style text. I use ISO standard. Just try to use ISO standard, and you can increase the height. And if you see here, the primary units, most of the students they have some mostly zeros, so you can control that from here. Anyhow, I'll show you that one. I'll just go here. Okay, so okay, set current, so it will be the current dimensions. Now let us start with the first symbol, that is surface roughness symbol. I want to say this one. But wherever you see this symbol, the triangle type of symbol, it's called surface roughness symbol. So let me just. So in order to draw that, you can just simply use normal line. And there are many ways to draw it. You can use some dimensions like 10, 10, but usually I'll show you one method. We use it like offset 7, then offset 15. I'll show you. Okay. Now I'm going to draw a point here. And then we need to draw 60 degrees on both sides. So I'll take 60. Maybe in the video you have some different dimension, but you can use any one. So I'm just trying to draw the symbol like this. So I did this symbol. If you see the dimension what I have taken here, from here to here, the small height I have taken is 7. The big height I have taken is 15. And on both sides, I have taken 60 degrees. If you can see that, I'll just try to remove this line. I can show you that angle. This one and this one. 60 degrees on both sides. I have taken 60 degrees on both sides. So this is how we draw a surface roughness symbol. Okay, but it's not like a fixed dimension. You can use some other dimensions like 10, 10, 20. And if you feel the size is small or big, for example, in some drawings, the dimensions will be big here, like, so in that case, this symbol looks very small. So in that case, you can increase the size of the symbol using scale. There is a command called scale. Using scale, you can increase the size of the symbol and make it bigger or smaller. Like for example, you select it, enter, select the base point. Now, if I type, see this is the scale factor. If I type 0.5, it will become half of the size. If I type 2, for example 2, it will be double. You see the size is increased. So you can also reduce or increase the size of any symbol or any object. It depends on the drawing. If you feel it is very small, you can make it bigger, and likewise. So for example, I'll just go back to put 1, scale, 0.5, like this. Likewise, you can put it. So what you do is you draw somewhere this symbol, because no need to draw every time. You can simply copy this, and wherever you need it, you can go for copy. Okay, just try to move it here wherever it is. Like for example, in the drawing, the symbol is here, so I'll put it here somewhere here, like this. And also have draw symbols here on the surface, so I can use the same symbol. I will copy it. It is on this surface, but it is rotated, so I can also rotate this symbol as well. I can rotate this. Okay, and then I can move the symbol somewhere here on the screen wherever it is there as per the drawing. So you have a number on the surface. We call the surface roughness value. There is a dimension for surface roughness symbol. So that's why we call it surface roughness number. But you can use it using text. There is a text, you know how to type the text. So use multi-line text and just select it here. And what is the number there? 6.3. You can type 6.3. You can use the different font as well. Also, you can increase the size if you feel it is very small or big. So you can just move it like this. Also here I have some another number that is 1.6. So it is must be rotated because it is vertically aligned. So you can just move it. So this is I'm using text to put the surface roughness value there on the symbol. So wherever it is there, you have to show it. And really important in this type of drawing is you need to show exactly in the same position, same format. You should not use another format. Okay, let us go to the next symbol, next line, leader line. How we are going to use a leader line? As I told you, leader line is actually a type of line with having one arrow at one end. Whenever you want to show something, we use leader line. You can type leader line, leader, or you will find this here also. If you go to the dimension, you can see here multi-leader. It's the same thing as leader line. Leader line is also called as multi-leader. So you can use that. When I select that, you see, for example, if I want to see, it comes with an arrow. Wherever you select, go, for example, I want to select here, it comes with an arrow. So that is called leader line. So in this case, there is a leader line here with some information for this hole. We have some hole here, small circles. I just want to let's go for multi-leader. You see, it's come with an arrow, and then I'll put like this, and I can extend the line because I want to write some information over there. Now this arrow, you can increase the size as well. If you see whether it is very small or big, you can just click it, go to the properties. Okay, you can see there in the properties you'll find the head arrow size. You see, you can increase it. Maybe if it is very small, you can increase it slightly, it can become bigger, or if it is bigger, you can make it smaller using the arrowhead size of the arrow of the leader line. Okay. Now here you have some information here. So I can use this text. I use the text here. Something 3 holes, diameter 6. So I can just type 3 holes, the 6. I use some other font, some information here. There is also some information down. So you can write quick, some code is there. All right. So you can just show the same information what is given on the drawing. Even when you have like a section like XX, this is also one type of text where it shows the sectional view. You have to show this as well. Don't miss anything. Then we covered little line, we covered text, and we also show text override. How you are going to override the text? For example, you have some dimension here. For example, I'll show you dimension here. This dimension is 20. Okay, this dimension is 20. The hole is 20, but you can see the drawing there is 20H8. How you are going to change this dimension? Okay, is using a text override. So if you see here, when I click this, okay, go to the properties. In the properties, you have an option called text. Go down. You see there is a text. And in this text, you have the last option called text override. This one. Using this, you can override the text. Override means editing, changing the type. For example, if I type space bar, space bar on the keyboard, okay, and enter, see the dimension is gone. So this is how we remove it. If you want to remove that number and keep the dimension line, we just type space bar. So for example, here I want to write anything. See, if I type anything, that will appear there. So whatever you type here, that will come onto the dimension. So here we need 20H8 as per the figure. So enter. So that will appear there. So this is how we do text override. You can change the dimension by using text override. Okay. This option is available inside the text. Okay. Next, we'll go to the geometrical tolerances. How we're going to put the rectangular boxes. Okay. Okay. We'll just, for example, here we have some geometrical tolerance symbol. So I'll use one line here. Somewhere from here. Okay. Now, in order to get the geometrical tolerances, option is available inside the dimension. You go here, you see multi-leader. Below this, you see tolerance. If you don't find it, just type tolerance on the screen. TOL, which is tolerance. Okay, when you select it, you will see a window. You see geometric tolerance. So this window will allow you to create the boxes. The boxes usually have a symbol, there is a value, some numbers. So depending on that, for example, if you want to put this symbol here on the left side, you can see the symbol, you can put the value, and these are the datums. Datums means surface, surface A, surface C. So this will cover in theory, what is the meaning of it. But here when you select this, you see this, you will get a symbol set. So you can select that symbol which is there in the box. If there is a value here, you put the same value here, 0.12. Sometimes you have diameter symbol, but it is not there, so you just leave it. And there is no second value, there is only one value here. And then we have datum A and C. A is at the top, you can type A here. And C is at the below, you type C below. This is how you put the same information as per the figure, and then say OK. So it will give you a box directly.
Teacher,
Yes.
in the biggest circle, there is
Mhm.
dimension 75 and
Yes.
plus or minus. What's the meaning of plus or minus?
I'm coming to that. These are tolerances. You remember in chapter 3 we started this week, I think last week, I think. We discussed about tolerances, limits, maximum limit and minimum limit. How we
Okay.
give them, okay? I will show you how you put that, how you change that tolerances, okay? Let me
Okay.
finish this geometry and then I'm coming to that.
Okay. Thank you.
Okay, so when you enter this data, see, automatically you will get the geometric tolerance box. And if you want, you can also increase the height. If you want to increase the height, I'll just increase the height maybe 4. See, the box slightly become bigger. You can also move it like this. So this is how you put the geometric tolerance. For example, I want to put here on the right side. For example, I want to put this on the 60. Mm, I'll use a line. Here you have triangle, but I'll show you before I put the triangle. Okay. Now, in order to draw the triangle, there is no dimension. You can just randomly draw it. For example, I'm just trying to draw a small triangle and just mirror it. Make sure that you have three side closed, and then I can go for hatch. I can go for black hatch that is solid. Okay, I got the triangle. So there is no dimension for it. Just draw a small triangle, close it, and then hatch it with a black pattern. Now I'm going to put the geometric tolerances here. Okay, just zoom in. Yeah, this one I want to put it. So I'll go for tolerance symbol. You can see what symbol is there. Okay, then you have 0.08. You write 0.08. Then you have B at the top, C at the down. So I'll type in the datum B and C at the down. So you can have it tolerance value. Type here, like this. Yeah, like this. So you can get that, tolerance boxes. We call it a geometric tolerance frame actually. It's a frame. So that you can create from the tolerance. Here also if you see there is a 50 diameter and to this there is one more, to that we have one more tolerance here with no datum here. So I can just go down. Okay, there's this, and then like this. And here I'll use the tolerance again. But here I have only one symbol and value, no datum. So now no symbol, 0.2. There is no datum, just leave it. So you can have that. Okay. Then I can just increase the size. Okay. So similarly, you put the tolerance frame wherever it is required. Wherever it is required, you can put it there. So if you know how to put it, you can put it anywhere on the drawing. Here, there is one more thing I want to show you here. There is 50.02. Okay. You can also change this. For example, I have dimension 50 diameter. I just want to remove this. I told you how to remove it. Go to the text, go text override, type space, enter. It's gone. Now I can use the normal line and I can use the multi-line text. I can type 50.02, right? But what you see the difference here? I put the dimension. I can change dimension, but the symbol, diameter symbol is not there. So this diameter symbol, you can put it inside the text. When you select the text, okay, you are inside the text now. Here, inside the text, right click of the mouse, this right click, okay, you see the option called symbol here. So you have a lot of symbols, angle symbol, plus or minus symbol, degree symbol. You see diameter symbol is also there. So you have to put the diameter symbol from the text, not on the screen. When you click, this is the right click. No, you go inside the text, right click here inside the text. Okay, you see symbol, select the diameter symbol. Okay, you got it now. See how you put the diameter symbol or plus or minus symbol inside the text. It is available like that. And the last one is the dimension tolerances. Okay, those limits, how you're going to change the limits. For example, here you have 75. 75 is the basic size. How you're going to change to uh, symmetrical dimensions, deviation, I will show you. Just click this. First you have to put the dimension, then click this, go to the properties. Okay. When you go to the properties, you have a last option. If you go down, last option called tolerances. You see tolerances. In the tolerances, you have here some options called, we have four options, symmetrical deviation limits. You see, if I select symmetrical, it will come in this way, plus or minus. If I put deviation, it will come like separately, plus separately, minus separately. If I put the limits, it will calculate by adding up the upper limit and subtracting the lower limit like this, the basic size. So likewise, now we need it here in a symmetrical fashion. So we go for symmetric. Okay, that is stored on display, and the limit is 0.5. The 0.5 is for both 75 plus 0.5 and 75 minus 0.5. So this will be here, you can put, because both are same, you can put just 0.5 here. Don't put 75 again here. Already 75 is there. So you just need to put the limit, what is there on the drawing. If I put the 0.5, enter, see, the 0.5 will appear there. So this plus 0.5 and minus 0.5. So this is, you can change, you see, if I change to deviation, it will become like this, you see, 75 plus 0.5, 75 minus 0.5. If I change to limits, it will calculate with the basic size. 75 plus 0.5 becomes 75.5. 75 minus 0.5 will become 74.5. This is limits. So in whatever fashion it is given on the drawing, you just appear to be the same. This is like this. Similarly, let's go to this dimension 60. Okay. Now, if you go to the 60, you see 60 has a different way of putting the tolerance, plus 0.15 and minus 0.00. There is no, the lower limit is 0. So if you go to the tolerance again, go down, go down, okay. Okay. This I'll put to deviation. You see, deviation means it will become like this. So this is a lower limit is 0, and the upper limit, you see, upper limit is 0.15. When you click it, it will become like this. I'll just change to deviation. Go back, properties, go to the tolerances. Here, if you go to deviation, the lower limit is 0, enter, and the upper limit is 0.15, enter. So you get that same thing here. Similarly, wherever the tolerance is applied or required, you can put it. Even if you need some zeros, you can remove it and you can add it. Like for example, if I go down there, there's an option called, say here, precision value. If I click it, see, it can be increased to many zeros as well. Then similarly, you have 40 here, 40 dimension. So for example, we go to here and here. Okay,
Teacher,
let's
there
go.
is a minus between
Yeah,
60.
minus. Yeah, it will be minus. Uh, Sometimes it will not appear, doesn't matter. It will be, usually the lower limit will be minus only. The upper limit will be plus. the lower limit will be minus. So there is no value. That's why it is showing uh, minus symbol is not showing. But usually, if you see the lower limit, it will come like this. See, this is changed to deviation. So I just change to symmetrical. What is let's say 40. 40 is 0 and minus 0.12. We can change it to here. Also, if you don't want to use this, there is one more method I will show you. This is deviation. And what is the size? Is 0 plus 0 minus, this is 0.12. It will become like this. Okay? Plus minus 0.1. If you don't want to use this method, you can also use text, multi-line text. For example, you can use normally, just you can use 40. Okay, I'm using this dimension. Also, if you want to use the limits, I can use say plus 0.00 and minus 0.12. In detail, you can use it. I use the change this type. Maybe I'll use 3 small. I'll put this small. So if you want, we can also use this kind of text in order to put the basic size and in order to put the limits like this. So you can also use this if you don't want to use the dimension. But in this case, you need to have a dimension line as well, this one. Now, for example, I will change this, go to the properties, go to the what is the text override. I'll type space, enter. It's will gone, so I can just simply move it here. You can use many methods. The only thing you must show exactly the same thing, how it appears on the drawing, like this. Okay? Like this. So you can use many methods. So likewise, you put it on the other. So you have to put every symbol. Don't miss anything, even a single letter. So this will, help you to practice because this is a part of final lab. So you must know how you are going to put those symbols, all the symbols with detailed information like detailed tolerances, geometrical tolerances, surface roughness symbols, and so on. Anyhow, you have the link for the video. So when you draw, just go to the video link. So that will help you to draw and put the symbols wherever it is applied. You see there is a leader line here. Use a leader line and type this information. This is a text. Okay. Yes. Which line you're talking about? On the left side view or front view? This one? On the left side. On the right side? No, there are two views. Okay. Yes. Uh, yes. I, yeah, I can understand. Yeah, what you mean is this one. You see, when you project this, it is not coming in the same, right? Actually, this one, if you see this line, it is a sectional line. This part is cut actually from the middle. Okay, when you cut this part in from the middle, when you open it, so this is actually the sectional view. Are you following? It is not. It will not come here because it is actually a sectional view. when you cut this inside the middle and you open it into half, okay, so you look like this. This appears to be here. Okay, so what you just need to do is you just mirror it. When you draw this, like for example, this hole, you draw this hole first at the top, and then this is actually the array. You know array? You know how to do array. Three items or four items, six items. So this is like array. For example, I'll delete it. I can draw such a here, for example. Where is that? So here, diameter 6. After that, we project this on the right side. We get this 6 diameter. And then for the other sides, you can go for array polar array. Select this one. Select the center. Okay. Okay, and you can put the number of items. I need it 3. For here, I need 3. Like this. That's how we get this. But this one will be half. It will be half like this.